Hi everyone, and welcome to the fourth and final video going through some past exam questions on the topic of the equilibrium constant, Kc. Yet again, the first question is always, seems to be anyway, write the expression for Kc. So in this equilibrium, again, it's products over reactants, so we're going to have NH3 on the top, square brackets to represent concentration, and we need to put it to the power of the number of moles, so that needs to be squared. And then the reactants on the bottom, so it's N2 to the power of 1 and concentration of H2 to the power of 3. Okay, what are the units? So we're going to substitute in moles per decimeter cubed wherever we've got a concentration. Okay, so we can see that we're going to end up with moles per decimeter cubed squared on the top, and we're going to end up with moles per decimeter cubed in total to the power of 4 on the bottom. So that is going to give us moles per decimeter cubed to the power of -2. And then if we sort this bracket out, we're going to end up with moles to the -2 decimeters to the +6. And then we'd write that as decimeters to the 6 moles to the -2. Although you would get away with this on the mark scheme. Okay. Then we've got our calculation question, but this one is slightly different. Okay, let's have a look what's it saying. Okay, they mixed together nitrogen and hydrogen and pressurized it, and so it's telling us the volume is 6 decimeters cubed. They left it to reach equilibrium. We know what the amounts were at equilibrium at 500 degrees. Don't worry about the temperature here. This is only here to show you that the temperature has stayed the same. Okay, we're not going to have to use this value in a calculation or anything. And it's giving us the value of Kc. Normally, that's what we have to work out. Instead, it's saying calculate the amount in moles of ammonia present in the equilibrium mixture. So this is kind of asking us to work backwards. Okay, so let's work with what we know. We know what Kc is. Okay, so let's put that in here. We know then that NH3 concentration of NH3 squared over concentration of N2 concentration of H2 cubed is going to be equal to 8 times 10 to the -2. Okay. We want to know the moles of ammonia, so we want to know this. Okay, this is the one we're going to end up calculating the concentration of ammonia and then converting it into just the moles. So let's rearrange this to get the one we want. So the concentration of ammonia squared is going to be 8 times 10 to the -2 times concentration of N2 times the concentration of H2 cubed. Okay, can we work out these values? Well, yes, we've got the equilibrium numbers of moles, haven't we? But that's not the same as the concentration. We need to divide by the volume, and the volume is 6 decimeters cubed. So we can work this out and put the values in here. Okay, so we can say the concentration of N2 is going to be 7.2 moles over 6 decimeters cubed. So that's going to be 1.2 moles per decimeter cubed. And the concentration of H2 is going to be 12 moles over 6 decimeters cubed. So that's 2. We can then substitute that in and say NH3, concentration of NH3 squared is 8 times 10 to the -2 times 1.2 times 2 cubed. Let's work that out. So 8 times 10 to the -2 times 1.2 times 2 cubed, which is 0.768 moles per decimeter cubed, because it's the concentration, isn't it? Oh, well, it's concentration squared, so let's not worry about the units. We now need to square root it, don't we, to get rid of the squared bit. So the concentration of NH3 itself is going to be the square root of 0.768. Which is 0.876. And then we didn't want the concentration, we wanted the number of moles of ammonia. So that's now in moles per decimeter cubed for the concentration. And we now need to multiply by the 6 decimeter cubed. So NH3 moles is 0.876 times by 6. Oh, I should have used the full number, shouldn't I? Rubbish. Let's go back. I'm going to have to go back to the start. Do use the full value on the calculator, because it's not 0.876, is it? It's 0.876, blah, 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 blah. Times 1.2 times 2 cubed. Oh, what have I done? Right, I'm messing this up massively. But times 1.2 times 2 cubed. Right, we get that. We square root it. And then we want to times that by 6. And we end up with, does it say do it to a certain number of significant figures? No, it doesn't. So I'm going to call that 5.26 moles. So although that's an equilibrium constant question, it's certainly not the standard question. It's just a bit of maths, really. It's just rearrange an equation and then substitute the values in, just being careful that there is a difference between moles and concentration. So again, just don't be freaked out if you get something a bit unusual. It's just a little bit of maths there. It's just not the standard method that you'd use. Okay. The last bit of this question is a bit more of a wordy one. So it's asking us about what's going on in terms of shifting equilibriums and values of Kc and whatnot. So they're saying we doubled the pressure of the equilibrium mixture and keeping everything else the same. As expected, the yield of ammonia increased. Right, is that what we would expect? Let's just have a look. If we increase the pressure, the equilibrium is going to shift to decrease the pressure. So it's shifted side with fewer moles of gas. Yeah, it would shift to the right. Okay, that makes sense. Oh, that's the question. There we go. So we just answered it. Why does the yield of ammonia increase? The position of equilibrium shifts to the right. Because the right-hand side has fewer molecules of gas. Okay. So then this last question is, I don't like this question. It's worded kind of strangely. It's saying, explain in terms of Kc why the equilibrium yield of ammonia increased. What this is really asking you is, explain what is going to happen to the value of Kc when I double the pressure. Why they've written it like this, I don't know. It's not very clear. If you get anything that says in terms of Kc, it's always the same question. It's basically saying, explain what's going to happen to the value of Kc. Is it going to increase, decrease, or stay the same? So we're going to approach it on that basis. I've had a check on the mark scheme, and it is that question, even though they've worded it kind of strangely. So what is going to happen to the value of Kc if we double the pressure? Well, straight away, changing the pressure does not affect the value of Kc. Okay, so we are going to get a mark just for saying that. Okay, the value of Kc does not change. And then we just need to explain why. Okay, so if we double the pressure, if we go back and look at our expression, what that's going to mean is all of these values are going to increase. Okay, because if we squeeze the volume down, then the number of particles per unit volume is going to increase, and that's going to increase all of these. Okay, but because we've got a total of to the power of 4 on the bottom and only a power of 2 on the top, it's going to increase the bottom more than the top. Okay, so that's how we're going to get our first mark. Okay, increasing the pressure. Sorry, it's going to get our second mark. We've already got one mark for saying this. Increasing the pressure increases the terms on the bottom of Kc more than those on the top. All those terms increase, but because we've got a total of a higher power on the bottom, it's going to increase the bottom more than it's going to increase the top. So that should make Kc smaller if the bottom is increasing more than the top. But the other thing we need to take into account is this equilibrium shift that we've mentioned here. Okay, what's going to happen is the equilibrium is going to shift to the right, as we've already said. So let's just put that in. The position of equilibrium shifts to the right. Which then, if we're shifting to the right, we're shifting towards the products. So that's going to increase the terms on the top of Kc. So what we've said then is it's going to increase the bottom more than the top, but then the equilibrium is going to shift and it's going to increase the top. So both the bottom and the top have increased, and those two effects are going to cancel out, which is why the value of Kc is not going to change. Okay. If you put those points, that is going to get you the marks.